So now that we've completed the lab, there's another part here. There's also a homework assignment. So if you go to the bottom left here, you're going to see two tabs. So there's a lab tab and also there's a homework tab. So now go ahead and click on the homework tab. And let's see what the homework looks like. So for the homework, so here you're given some data. You have to load and extension, and what you want to plot is extension versus load. So let me remind you what that means here. So I'm not going to give you the exact answer, but in general, if you have y versus x, that means that the y part is going to be on the vertical axis and the x is going to be on the horizontal axis, and x is going to be the independent variable and y is going to be the dependent variable. So here you're going to do the same thing. So you're given some data, you're given load versus extension, and you're given load and extension data, but what you want to plot is extension versus load. So you're going to have to decide based on what I've just showed you here, which one is going to be on the vertical axis, which one is going to be on the horizontal axis. And you'll input the data here. So here, unlike in general, you have to convert from grams into kilograms, for example, from centimeters to meters. But here you can leave these units as is. You can use grams and centimeters for your units. So what you're going to have to decide is which one of these represents the independent variable in terms of its name, which letter represents the independent variable, and also the corresponding units, which you can leave. But you can see right there, you have just options of grams and centimeters, so you don't need to convert. So and then you'll just have to transfer your data, transfer the data here onto this section. So that's going to be part one of the lab. Part one of the homework assignment. Part two, it's actually a continuation here. So once you've gotten the data, you're going to create a graph just like we've done before. So you're going to create a graph and put it here. So let me just add some numbers myself just so I can get a sample graph. And so now, let's see. So we're going to create a graph just like before. So let's go ahead and do that. So select the data, and you're going to go to Insert, and then Charts. And you're going to select Scatter. So there's just two data there, but that's not the important part. So now you're going to create a graph, so you should know how to do that now. The new thing is we're going to add error bars. So let's see how to do that. So here it says that you're going to want to add error bars with a value of 0.3. So just click on the chart and go back to chart design, and then go back to add chart elements. This time you're gonna pick error bars, and once you pick on error bars, you're gonna go to more error bar options. So when you click on that, this is going to appear, and you want to pick a fixed value, and the value that you want to pick is the number that's given here. So you're going to put 0.3. I guess because my numbers are too big, it's not showing up. So let me see if I'm just going to pick some bigger numbers so that you can see it. So let me just redo that. So you're going to enter 0.3, but I'm going to enter some other numbers. So let's go back into add the error bars, more options. Let me make it 50. Yeah, it's too big, but still, let's just make it 20. So there it is. So you've added error bars. So you're going to have to add the error bars that correspond to this value, but here This just show you this. This shows you the steps in order to get the error bars. So we're just gonna go to add chart elements, and then error bars, and then more error bar options, and then you're gonna pick the fixed value. So that's something new for part 2 of the homework. And let's see what else. Everything else you should be able to do here. So now for part 3, again, you're given some data. So let me explain this one here. So you're actually given, so part 3, this is a exponential, it's a radioactive decay that involves exponential growth. And you're given 3 columns. So you're given time, you're given a number, and you're also given the natural log of the number. And so here what you want to do is pick the date with the columns that are going to be already linearized. So you have, you know, numbers here, some numbers here, and some numbers there. So you're going to have to pick which 2 of these. Is it these 2, or, you know, is it these 2? You're going to have to pick 2 of those that represent the linearization. So once you decide which 2 of those columns are going to linearize the data, then that's what you're going to enter here. And also remember that you'll select based on this option, which of the 2 variables need to be linearized. And then once you selected the variables that represent linearization, then you're going to plot that. And once you plot that, you're going to put the slope here. And you're going to record the slope over here. So this part is also something that we've seen before. And the last new thing, let me see if there's anything more here. Yeah, that's actually it for the lab. So the last new thing is to get what's called a time constant for this exponential growth. So let me go ahead and explain that. So you're given an equation that has a general form z equals ln of n0 and minus t over tau. So t over tau, and tau is the time constant, and that's what we want to find. So let's just reorganize this equation. So if you organize it so that we have z equals negative t over tau and plus ln of n sub 0, then here this equation is going to have the form y equals m times x plus b. But instead of x, I'm gonna use t for the independent variable. So in this case here, m is gonna if we ignore the negative sign, m is gonna correspond to this term here. So in this case, the slope, if we ignore the negative sign, is gonna correspond to 1 over the time constant. So in order for you to get the time constant, then it's just gonna be 1 divided by the slope. So let's say, for example, here then you calculate your slope, and let's say that your slope is going to be 2, then your time constant is going to be 1 over 2. So from here we've completed everything that we need for the first lab. So from here on then you can complete the rest, and if you have any questions, please let me know. Good luck.